Here is the review video for the Chapter 1 test. We're going to take that test Wednesday the 28th. Okay, we did this review in class, but just to go over some more of it. Okay, the first section on your test is going to have you answering questions like this, where you first have to write out the expanded form. So 2 to the negative 4th power tells me make a fraction, 1 is on top, and then 2 times 2 times 2 times 2 on the bottom. This part is going to be where you answer in standard form. So we've got this section that we're answering in expanded form, and this section that we're answering in standard form. Alright, the next one says 3 to the 4th power. Well, that's nothing special, no negatives, no fractions. So it's just straight up 3 times 3 times 3 times 3, which is 81. Next one is 2/9 to the 3rd power. So 3 2/9. Then 2 times 2 times 2 is 8. And 9 to the 3rd power is 729. And I did not do that in my head. You should be not doing that in your head. That's what a calculator is for. Hopefully you're using that. Okay, -5 to the 4th power. It's the base that's negative, not the exponent. We're not making a fraction. If you type this into the calculator, remember to put parentheses, because without parentheses, it is a totally different answer. The number would be the same, but the sign would be wrong. So this comes out positive because 2 negatives make a positive and 2 negatives make a positive. This section is all calculator work. Here you are allowed to answer as a decimal. So for example, if you did the first one and you typed number 5 into the calculator, you get 0.013 repeating. And it would be totally fine for you to leave that answer. If you were to figure it out as a fraction, it would be 1 over 75. Okay, so this would be 1 over 3 times 1 over 25, which is 5 squared. And so you could figure it out that way by hand. But these are 2 possible ways that you could express this answer. They are the only 2 possible ways you could express this. Number 6, we're just typing it into the calculator. There's nothing we can do with the 2 and the 3 that's a shortcut. Multiplying 2 times 3 would be wrong because you have exponents, and exponents come before multiplication when the bases are different. So this answer comes out 432. Number 7, you could express this one in exponential form a different way. You could distribute the outside exponent. So you could have 2 to the 4th power times 6 to the 4th power, and that would be acceptable. Or you could $20,736. So either of those is okay. Number 8, you can just type it in, and you get 256. There's really no other way to express that answer according to our directions. Okay. All right, in this section, there's a couple problems I'm not going to do. Raising 1 to an exponent is kind of useless. And this one's going to come out a negative as a fraction, and I really don't feel we need to do that. So on this section, the important thing to remember is that if it is a multiply problem, first of all, you're going to keep the base. no matter what kind of problem it is. Keep your base. So I could start off this entire section on my test just writing 9, 7, 5, 3, 2, 4, 6, 8, 10, and -6. Remember, that has to go in parentheses. Okay, I could start out the whole test, this section, not the whole test, this section of the test, just writing in the bases so that you don't mess that part up. The next thing to remember is that if it's a multiply problem, you add your exponents. If it's a divide problem, you subtract your exponents. And if it's a power to a power, you multiply exponents. So the very first one is a multiply problem. So -2 plus 5 is 3. The very next one is power to a power. -2 times 4 is -8. Remember, anything with a negative exponent, we're going to want to make into that fraction with 1 on top and change your exponent to positive. -2 plus -6 is -8. Same thing. 1 over 5 to the 8th power. 12 take away 3 is 9. Nothing to change there. Alright. We get a little tricky here. Watch your signs. -4 take away -6 is actually a +2. Okay. -8 take away 2 is a -10. So that's 1 over 4 to the 10th power. 6 to the 8th, multiplying exponents, -12th, so 1 over 8 to the 12th. This is a multiply, so 10 to the 3rd. This is a multiply, so add 2 plus -5 is -3, which we make a fraction. 1 over -6 is the base. It stays the same to the 3rd power. Alright, convert the following into standard form. So we have 8, and we're going to move the decimal over 1, 2, 3, 4, 5, 6 times. So I need place holding zeros here. So that comes out 8 million. Number 22, we've got a negative exponent here, so I'm going to move the decimal to the right, or to the left. 0.03. Number 23, 5.5. The exponent is 4 and positive. I'm going to move to the right 1, 2, 3, 4 times. We got a negative exponent, so we're going to move the decimal 1, 2, 3 times. .00631. Remember, for this section, this work that we're doing, moving the decimal, is not final answer. You can't put that on the line. It has 2 decimals. Every one of these answers, or some of you want to make answers, have 2 decimals in it. A final answer cannot have 2 decimals. So you need to put a clean answer on the line. Okay, next section, we're converting regular standard numbers into scientific notation. So the first one of this section, we're putting the decimal after the very first non-zero number. So it would be 5 point, now there's no numbers, there's only zeros after that 5, so we don't need anything else except our times 10 to the 1, 2, 3, 4th power. The next one, we have all zeros, we hit a 2, so after that first number, 2.2 times 10, 1, 2, 3, 4. Now it's the -4th power because this is a decimal. Number 27, we're going to put a decimal after the 1, 1.7 times 10 to the 1, 2, 3, 4, 5th power. And 28, put a decimal after the 6 times 10 to the negative 2 power. Again, that's a decimal, so it gets a negative exponent. Alright, 29, 30, and 31. We're always looking for the larger exponent when we're comparing. So we've got a 5 and a 6 for exponents. That makes this automatically bigger. Even though 5 over here is more than 1.9, that's like saying what's bigger, $8,000 or $2 million. When it's a larger exponent, it's a larger, longer, more digits number. Okay, if you have a positive exponent versus a negative, that's always bigger. And now I've got two negative exponents. The one that's smaller is actually the bigger one when you're talking about negatives. In the next section, we're answering questions based on this chart. During which year were the most trees planted? So I'm looking first at my exponents. I've got a 4, a 3, a 4, and a 5. The biggest one wins. 2012. 33. During which year were the fewest trees planted? So we're going to go for that smallest exponent. So that's 2010. Then it says, what is the total number of trees planted in 2009 and 2011 combined? Those keywords are telling me add. And remember, even though you may be using a calculator to add, you have to show work. What you type into the calculator, telling me that, writing that down, counts as showing me work. So 5.2 times 10 to the 4th plus 8 times 10 to the 4th is the 2 years that we're worth of data we're adding together. Okay. If you do this on your calculator is going to say 132,000. Okay, but we have to answer in scientific notation. So our final answer is going to be a decimal after the 1, so 1.32 times 10 to the 1, 2, 3, 4, 5th power. And number 35, how many times more trees were planted in 2012 compared to 2011? Okay, the ones where it says how many times, you're setting up a division, and in that division the bigger number goes on top and the smaller number goes on the bottom. So 2012, 2 times 10 to the 5th, over 2011, 8 times 10 to the 4th. Now, very important in division is to put these parentheses into your calculator. If you don't, you will not get the correct answer. Now, very often these problems do not come out as really big numbers, so we don't have to answer this one in scientific notation. In fact, if you divide this one out, you get 2.5. Here again, I want to see you set up this division and the answer. Remember that I give partial credit. So if you set up the division correctly on your paper and you show it to me, and then somehow you make a typo with the calculator and you come up with a different answer than 2.5, I can still give you partial credit for having the correct setup. It shows me you knew what to do, you just made a typo. If you don't show this to me and you get the wrong answer, I have to take away full credit because I have no idea what you did wrong. This next part is adding and subtracting values that are in scientific notation. Okay, so for the first one, if I Added or subtract. Now this is one where we could actually use the shortcut if you wanted to, and it'll work out. See, I see the same exponent, and I see that 5.7 plus 4 is going to be 9.7, and then keep our times 10 to the 5th, keep our exponent. If you did not do that, if you typed it in anyway, which is fine, you're going to get 9, 7, 1, 2, 3, 4. 970,000, and then you would just put that into scientific notation. Okay, this next one is 5.6. These also have the same exponent, but the shortcut's not going to be too helpful because 5.6 minus 5.1 is 0.5, and that's not a single digit number in front of the decimal. So I'm probably going to play it safe and use the calculator. So 5.6 times 10 caret negative 4 minus 5.1 times 10 caret negative 4. And the calculator says 0.023, 4 zeros and a 5. So I will then put that into scientific notation by putting a new decimal after the first regular number. So that's 5 times 10 to the negative 1, 2, 3, 4, 5th power. Okay. This next one has standard notation and scientific notation. So we're going to plug that into the calculator. 210,000 times 2.2 times 10 caret 6. And actually when I plug this into the calculator, the value is so big that it doesn't fit on the screen, so it converts us to scientific notation automatically, which is kind of nice. Okay, number 42, we could apply our shortcut for division if we want, which is 9 divided by 2 is 4.5. It's division, so we'll subtract our exponents. 5, take away a negative 1 would be the same thing as plus 1, so that would be 6. But if you type this into your calculator, you will get 4, 5, 2, 3, 4, 5. And then you put a decimal after the 4 and get 4.5 times 10 to the 6th power. Okay, so these other problems, the odd numbered problems over here, I did not go over in class because time just doesn't allow for every review problem. But if you are watching this video and you did these problems, you can check your work right now and see how you did. Okay, lastly we have these word problems. And your first goal in the word problem is to determine whether you're adding, subtracting, multiplying, or dividing. So number 44 says 9 times 10 to the 4th people live in Chemung County. 2.92 times 10 to the 4th people live in the city of Elmira. How many people live in Chemung County that do not live in the city? So let's draw like a really rough map here. Let's pretend this square represents Chemung County, and that's 9 times 10 to the 4th people. Now we're talking about the city of Elmira, and that's 2.92 times 10 to the 4th. Okay, so the whole county is this 9 times 10 to the 4th. Some of those people live in Elmira. We're talking about all these people that don't live in Elmira. So that means I'm going to be setting up a subtraction. 9 times 10 to the 4th minus 2.92 times 10 to the 4th. Okay, it is critical to get full credit that you write down that subtraction problem, because if you make a typo in your calculator, I can see, oh, you knew what you were doing. You knew how to do the question. Okay, so if you type it in, you get 6. Hold on a second. Oh, yeah. Your calculator will say 608 60,800. And that's 6.808 for a final answer in scientific notation. 6.08 times 10 to the 4th. And I made that exponent look way too big compared to the 10, so be careful of that. Make it small. The average person consumes 3 times 10 to the 3rd calories at Thanksgiving dinner for dinner. How many calories do the 2.92 times 10 to the 4th people who live in the city of Elmira consume? So we're saying one person consumes 3 times 10 to the 3rd calories for Thanksgiving. So what if we had lots of people? Lots of people. Okay? That means, 29,000 people. That would be a lot of calories. So the only way we're going to get that is if we multiply. So the calories for one person times the amount of people. Type that in. Remember that your calculator in class understands that parentheses next to each other means multiply without putting the multiply key in there. And you get 8, 7, 6, 1, 2, 3, 4, 5. So for a final answer, we have a decimal here, 8.76 times 10 to the 7th power. Okay, now remember the shortcut for this is I could do 3 times 2.92 and I would get 8.76 and then add my exponents. That works in this particular case because when I multiply 3 and 2.92, I don't get a number larger than a single digit in front of the decimal. So I have to be careful. I can use that shortcut on this particular problem. And the last problem on our review. A sheet of paper is 2.8 times 10 to the negative 3 inches thick. A ream of paper has 5 times 10 to the 2nd sheets in it. How thick is a ream of paper? So imagine you have one piece of paper and a ream of it, like a package of paper. 5 times 10 to the 2nd power is like 500. So imagine 500 sheets of paper in a stack. Okay, so this is another problem where we end up multiplying. 2.8 times 10 to the negative 3rd times 5 times 10 squared. Now I can't use my shortcut here because 2.8 times 5 is going to be larger than 10. So I'm just going to go ahead and type the whole thing in. 2.8 times 10 caret negative 3, open parenthesis, 5 times 10 caret 2. And this answer, actually, the calculator answer is sufficient, 1.4, because that's a number that's so small, scientific notation is not necessary or even helpful. Okay, so that's the end of the video. Study hard. I will say that the actual test, I've cut back on the questions. I won't tell you which ones. Any questions like this are fair game, but I've cut back on how many questions you're going to have to do. It's not 46 questions long. Happy studying, and I'll see you tomorrow.